Let's find the 100th number using our knowledge of lines. 2, 5, 8, 11. We're going up by threes. Plus 3, plus 3. We know that y is equals to mx plus b. So here, because we're going up by threes, our slope m is 3. So y is equals to 3x plus b. Now what is the b value? When x is 1, which represents the figure number, 3 times 1 is 3. As you can see, the number 2 here is a little bit smaller, so we're going to fix it by subtracting 1. And now we have the equation. To verify the equation y equals 3x minus 1, let's substitute x equals 2, which represents the second number, the second figure. 3 times 2 is 6, minus 1 is 5. So indeed, this works. You can plug in x equals 3. 3 times 3 is 9, minus 1 is 8. So the pattern continues on forever. So to find the 100th number, we simply substitute 100 into x here. So y is equals to 3 times 100 minus 1, which is 300 minus 1 is 299. Now let's find the common difference d. We go up by threes. So the common difference, the second number minus the first, or the third number minus the second, is 5 minus 2 is equals to 3. This is our d value. And the first term, t1, is simply 2. t1 is sometimes referred to as a, which is also sometimes referred to as u1. Now let's find the 100th number using the arithmetic sequence formula. T to the n is equals to t1, term 1, plus n minus 1 d. So we know that we're interested in the 100th number. So n is equals to 100. Our first term we found previously was 2. Plus n happens to be 100, the 100th number. And our common difference d is 3. Now we simply need to use algebra. This happens to be 99 times 3, which is 297. So our answer, plus 2, is simply 299, which matches our previous answer over here. So feel free to use the arithmetic sequence formula or to use a line equation. For question 2, let's explain why the arithmetic sequence formula works. The unknown term is the first term plus n minus 1d. Now suppose the arithmetic sequence is 5, 8, 11, 14, etc. We're going up by threes. Here our first term is n equals 1. We have the second term, the third term, 4, 5, the sixth term. Now, how do we know what Tn is? The last term. When n equals 6, we know the last term is 20. Now, we use the formula. The last term, which is 20, is equals to the first term, t1, which is 5, plus a bunch of d's. And here, d is equals to 3. Something times 3. How many d's are we adding? Plus d, plus d, plus d, plus d, plus d. 1, 2, 3, 4, 5. So we're multiplying by n minus 1d. So this formula makes sense.